All right, in this lesson we are going to look at how to read a cladogram, and this is this is a kind of tool that is used by scientists to show the relationship between two organisms. How closely related are they? How distantly or how recently did they have a common ancestor? Those sorts of things. So if you haven't done so already, I need you to pause the video and go to look up this YouTube video because this is kind of the basis of our lesson today. It's a deep look, one of the deep look series, and it's called Roly Polies Came from the Sea to Conquer the Earth. Okay, so go and find that one and take a look at it before you move on. In class, we started off by watching that, and we discussed a little bit what is this organism below. I think if you had a childhood like mine, we would find these under rocks, right? And they would roll up into little balls to protect themselves. And I actually didn't know a lot about it until I started teaching this class. And so some of the things that we generally know about them is we can find them in kind of damp areas, right? Moist areas under rocks. But other than that, I just thought they were a pretty normal bug. But it turns out that they used to live in the sea, as you hopefully found out in that video. And one of the quotes that I really appreciate in the video is that over evolutionary time, species make big, life-changing leaps, and those stories are written on their bodies. So one of those stories that's written on the body of a roly-poly is that they used to live in the sea, and this evidence is that they still have gills. I think that's so cool. They don't have lungs, they have gills, and this is left over from the fact that they used to live in the ocean. So that was kind of used as a way to launch ourselves into reading cladograms. These are cladograms. These are diagrams of relatedness among organisms. So if we take three organisms, A, B, and C, we can divide them up and show how related they are. And in general, when we have the species names, okay, let's say this is species A, species B, species C, this this part of the cladogram is going to indicate a long time ago, and this would be today. Okay, so we are moving in this direction towards the most differences between the species. So they started off as a single organism, and at some point, species C kind of went its own way. Okay, it may have moved into a new environment. It may have experienced a different kind of environmental pressure, and that pressure, those forces may have led species C to develop different traits. Okay, now A and B were still one organism until about this point in time, when either A moved into a different environment or B moved into a different environment. But whatever the case was, A and B at this point in time became two different species. Okay, so when we look at a cladogram like this, we can see that A and B are two different species, but they are more closely related because they had a common ancestor as far back as this point in time. Whereas C is more distantly related to A because their common ancestry happened farther back in time. Okay, so there are cladograms that look like this, and then there are also cladograms that look like this. These are basically saying the same things. When two different organisms become different species, that's when you see a split like this. This is the same thing that's happening right here. So these two cladograms would be saying the same things, just in different formats. Okay, so back at this point in time, A and B and C were all the same species, and we would say that that's the common ancestor. Again, at some point, C may have moved into an aquatic environment, or maybe started getting hunted by certain predators, or something happened and they started developing different features and became their own species. Okay, whereas A/B remained the same species until later on in life. Okay, in evolution, I should say. So if we look at another cladogram, okay, this is kind of following the diagonal format. At this point, we start again. We're moving in this direction towards modern day times. We have tortoises and horses and wolves and leopards and house cats. These are all organisms that still exist. But what this cladogram is showing is that at one point they were all one common organism, and at some point the tortoise developed into its own species, and it moved away from all of these organisms which had hair as a trait. Okay, these are traits that are going to be found in everything after this point. Okay, so horses have hair, wolves have hair, leopard and house cats all have hair. Okay, at some point the horse experienced some kind of selective pressure and developed into its own species here. And prior to that, all of these organisms may have eaten maybe they had different dietary needs. At this point, carnivory or meat-eating diet developed. So the horse was not carnivorous. The tortoise is not carnivorous, but everything after this point was carnivorous. Okay, so wolves and leopards and house cats are carnivorous. The wolf experienced some kind of environmental pressure that kind of forced it to become its own thing, its own species. At this point, retractable claws developed. So the leopard and the house cat would have retractable claws. The wolf would not. The horse does not have retractable claws. Okay, purring developed later on after the leopard had become a species, and so that is only found in house cats. Yeah, so that's one way to read this cladogram. Let's look at another one. This is kind of a complicated one, but the point I wanted to make on this one is that time is now moving in this direction. Okay, we don't have these species right now, but if this is a kind of a cladogram of how different dinosaurs evolved over time. Same idea, you just have these kinds of separations of the different species, and they will often show you what kind, in this diagram they want to show you what kind of skin or outer skin covering, I guess, they had in each organism. So these guys would have scales. Okay, so these would have scales. Anything with this marking would have scales. Filaments, plumulaceous feathers. Okay, so some kind of feathers, and also pinnaceous. So two types of feathers here, just showing the diversity of integuments or types of skin. Okay, here's another one. You have lampreys, sharks, ray-finned fish, lungfish, amphibians, and land vertebrates. So the common ancestor, again, would have been back here. And this trait is vertebrae, which means that all of these organisms have vertebrae because they came after vertebrae developed. Okay. Now, if you were to ask, well, which organisms have bony ribs and a shoulder girdle? Let's move me over here. Okay. Bony ribs and shoulder girdle, that would be found in, I'm going to give you a few seconds to think about this. These would be found in all organisms after this point, all organisms that became that species after this point. So that would include ray-finned fish, lungfish, amphibians, and land vertebrates. Okay, one last question would be, which ones have fingers and toes? Okay, so the only ones with fingers and toes are the ones that became species after this point. Okay, so the amphibians and land vertebrates would have fingers and toes, while the others that became species before that would not have this feature. Okay, here is a cladogram from the Deep Look video, and the question we can focus on here is how recently were they the same organism? Okay, so here's our common ancestor. This is kind of rinse and repeat like we've been doing this entire lesson. But here we see this split between arthropods with jaws and arthropods with fangs or pincers. Okay, so these guys kind of went in this direction. All of the blue arthropods had fangs or pincers. So scorpions and mites and spiders, all of these have that feature, whereas these arthropods have jaws. Okay, and they also divided up into different species, so ladybugs and centipedes and millipedes, and even one that's extinct right now. See how that that line stopped right here because it is no longer part of the existing community of arthropod species. Okay, so if we asked the question, what is the most closely related arthropod to centipedes? Okay, we'd have to find the centipede. Okay, now the most closely related one is going to be the millipede here because they were the same thing the most recently. Okay, their common ancestry was right here. At this point, millipedes and centipedes were still considered the same organism. Okay, centipedes are a little more distantly related to ladybugs, but you would have had to go farther back in time to find when centipedes and ladybugs were basically considered the same organism. Okay, let's see. Hopefully that makes sense. Pillbugs and scorpions show up next to each other on the cladogram, but you'd have to go all the way back here to find their common ancestor, right? Because they took different routes to become the species that they are today. So hopefully that makes sense. Make sure you understand which direction that time is moving and what is their closest relative in the cladogram. Those are kind of the main points. And also, what do these different divisions mean, right? At what point do certain traits develop, and what that means for these organisms.